In the previous lessons, we saw some example where the signal and variable types were of the type bit or standard logic. Now we try to formalize these two different types. The type bit is a predefined type in vhdl as seen before. Bit can assume only two values, 0 and 1. You may say, okay, this should be enough to model my design a silicon chip. You are right, but think about if you need to model something like this, an output buffer with an external pull-up or external bidirectional buffer with a tri-state output. In this case, we need something that can model the pull-up. That means at least three values, 0, 1 and pull-up h. Or the tri-state, that means at least three values, 0, 1 and tri-state. To overcome these needs, let's introduce the standard logic U type. This type is defined in a IEEE standard logic package. I'm sure you noticed this code as header on any vhdl file. The standard ulogic is a 9 values type where U is unknown. That means it's value of a signal or variable that is not initialized. You will find U every time you forget or not initialize a signal or of a standard ulogic type. X means that there is a conflict, for example, two signals connected together where one signal has the value 0 and the other signal has the value 1. Okay, you can raise an exception that the ulogic standard is not resolved. In fact, you are right. Next, we resolve also this question, but by now let's see the other value. 0 and 1 is the nominal value. Z means high impedance. W is a weak unknown. For example, two signals connected together, one signal has the value weak 0 and the other signal has the value weak 1. Dash is don't care, used if you want to implement a circuit in which the value of the current signal is either 0 or 1. As noticed before, standard ulogic is a no-resolved type. Now we try to understand better the meaning of the resolved type. Suppose to have the situation like this. Two tri-state buffers connected together with the output enabled. In this case, the output enabled is active low. The buffer on the left side drives a logic level equal to 0, and the buffer on the right side drives a logic 1. In this case, on the bus connection, we have a conflict. Now, how the simulator can model this kind of situation? Using the type bit or standard ulogic, there are no way to model these circuits. In order to model such type of situation, the standard logic type has been introduced. The standard logic type is a resolved type. That means, using this object, the simulator has the capability to resolve a conflict like this one. The standard logic type, as also the standard ulogic type, is defined on the 1164 standard logic package. In order to understand how the conflict in the bus connection is resolved, you have to play the battleship. Select the row where there is the entry with 0. In this case, this one. Next, select the column where is the entry with 1, the second one entry. On the intersection, we can find the result that is X. X means conflict. This example is similar to the previous one, but no conflict is present. The buffer on the right side is disabled. That means it is disconnected from the bus and it is driving a tri-state. In this case, on the bus is present only the buffer on the left side driving 0. The pull-up is represented with H. Playing the battleship, we found that the result on the bus is 0. In fact, H loses against 0.